Hello, this is Dr. Lori. Welcome to this discussion on the concept of risk for disease. Let's start off by having an actual definition for this concept of risk. Now, in everyday language, risk is defined as a lot of different things, but in epidemiology, we have a very specific definition for risk, and according to Rothman, that definition is the probability of an event during a specified period of time. And so here we have some kind of an event occurring. Now, if you think about an event occurring for an individual in whatever that period of time, a month, a year, a decade, whatever, for that individual, it will either happen, so a yes, or it will not happen. And for that particular individual then, the probability of that event is either 1.0 or 0, 100% or not at all. So the probability of an event occurring for a specific individual then is not very useful. However, when we take that same concept and apply it for the whole entire population, we have a whole bunch of individuals who are either a 1 or a 0. And so what that then extrapolates to over the population, the probability of an event occurring for that population during a specified time period is anywhere between 0 and 1, inclusive of 0 and 1, but somewhere in between is also possible. So hopefully, this notion of probability of an event occurring during a specified period of time sounds like a familiar thing, because what you've already learned is a concept called incidence. And incidence is, if you remember, new cases divided by the population at risk for a given location during a specific time period. So, and the location and time period is the same for the population at risk and the new cases. So a lot of epidemiologists correctly will use incidence and risk interchangeably. So really, we're just expanding on a concept that you've already learned. So here we have incidence or risk of an event occurring for a population during a specified period of time. And a lot of times for that population, that really defines our location. Not always, but if we're saying for a specific state or city or county, then that's our location. And the time is often over a given year, but it could be a shorter time period or a longer time period. So I want to take a little bit of a diversion. I want to talk about something called descriptive epidemiology. Now, descriptive epidemiology focuses on three specific things. First of all, a lot of times we're looking to evaluate trends in descriptive epidemiology. If you've ever seen some kind of a line graph and it has years at the bottom, 1990, 1995, 2000, 2005, 2010, 2015, and then you see a bunch of lines that go across, that's really looking at trends over time. And the lines represent whatever those events that are occurring, a lot of times the probability of those events per 100,000, and so we're looking at trends over time. A second reason, and this really ties into the whole concept of the the whole notion of the 10 essential services. And this has to do with descriptive epidemiology as a support for allocation of resources. And so if we're thinking about making a policy or doing a program or evaluating an environment, what this does is if we do some kind of descriptive epidemiology where we can locate populations who are at higher risk of disease, then we can allocate those resources in a way that's going to give us the most effectiveness for the amount of money that we have to spend. A third notion is the idea for descriptive epidemiology is we're really looking for problems that maybe we need to do more analytic epidemiology. Now, analytic epidemiology is a special type of epidemiology. Descriptive and analytic really are sort of along a continuum, and analytic really focuses a lot more on studying causation or causality. And so we want to know, does this exposure or this demographic or this thing, does it cause this particular outcome? And so for analytic, we use different kinds of study techniques, we ask different kinds of questions. Really, we're looking to see what kinds of problems we want to study. So in descriptive epidemiology, we do the first part of that. We say, well, where should we start? So descriptive epidemiology can be really used in a variety of different ways. We will probably focus a lot on evaluating trends, but just know that if you're doing any other kinds of public health, where you're looking at policies or environment or social and behavioral, a lot of times we're thinking of the question that we're asking is allocation of resources. We're identifying problems that we want to analyze for etiology. Now, how do we do descriptive epidemiology? We really often start by just noticing something. And case reports and case series are often at a very local level. Somebody says, wow, I've had this unusual large number of people with this particular thing. When the HIV epidemic started, they were noticing certain cancers that were happening in young men, and these are the kinds of cancers that historically had only happened in really, really old people. And so they said, in the last year I've had like 5 of these, and this seems unusual. So we write up the case report, publish it in a journal, and see if that resonates with anybody else. Maybe there are several case reports. We do a case series, and we want to see, are there lots of these that are happening. And so maybe multiple physicians or dentists or public health workers will sit around and say, wow, we've really started noticing that something's up. And so the thing then that follows often from these case reports, I notice something is going on, is we do something called a cross-sectional study. And really, that's a very descriptive name, because cross-sectional means that we're just taking a slice out of society. If we were to say, here's our time continuum, we measure exposure, we measure outcomes, we measure all kinds of things at all exactly the same time. And a common cross-sectional tool is a survey. We might just ask questions, and we ask you all about how much do you sleep, and do you have these behaviors, and do you have this kind of support system? And so this cross-sectional study is a very common way of doing descriptive epidemiology. You'll find out when we talk more about cross-sectional studies that one of the downsides is that we cannot establish causation, and that's where the analytic studies come in, where we want to do something that we can establish cause or etiology. So right now we're really kind of in the simplest forms of study design. We are doing just descriptive epidemiology. We're just describing things. And so that really then ties into the goal of this concept for risk of disease. We want to describe patterns of disease. And patterns based on what? The 3 very common things that we want to describe patterns of disease on are person, place, and time. And I know that just in your life growing up, you've probably heard those things. So person, place, and time can really be helpful to us in terms of describing how these patterns, this disease happens not just randomly in the population, but it happens more concentrated based on characteristics of a person or characteristics of a place or during a specific time period. So let's talk about some of the common things that we study in terms of person, place, and time. So there are several things that we like to think about in terms of person. One of them is age. And if you think about age, I'm going to go to another graph here really quickly. If you think about age is one of the things that across the board really helps us think about the types of diseases that are happening and the types of causes of mortality. And so here we have GBD compare. You could go here and explore around. I have the location as global, in other words, everybody. And in terms of the age ranges, if I go to the under 5 age groups, notice how over here age is listed, you'll see that worldwide, this orange expands rapidly. So orange has to do with kind of neonatal, infectious kind of causes of disease, preterm, encephalopathy, sepsis, malaria, meningitis, measles, lower respiratory infections, diarrhea, and so that becomes huge. The blue, or the chronic diseases, is much smaller in this group, and then the green, which is kind of injury related, is also quite a bit smaller proportionately to the whole entire number that is experiencing mortality. If we go to the 15 to 14 year age group, then you'll see that infectious gets a little smaller, and that makes room for a little bit more of the chronic disease and a little bit more of the injury. You'll notice that drowning is a major cause of death in this group worldwide, as are road injuries and some other kind of injury-related things. The 15 to 49 has the lowest mortality overall, but it still has some. It kind of like is a little U-shaped curve. And so chronic diseases start growing. Infectious diseases, people's immune systems are functioning really, really well compared to childhood, and injuries then starts going up. We see self-harm and violence as some major causes of injuries in this age range, and specifically road injuries, where in a lot of countries, these young adults are becoming drivers. They don't have a lot of experience, and so then they may have mortality due to road injuries. As we get to the 50 to 69 age group, you'll see that chronic disease really, really expands. It's not that the other things can't cause death, it's just that proportionately these things are growing so much more rapidly. Ischemic heart disease, stroke, all the different kinds of cancer, diabetes, COPD, lung disease. So these are the kinds of things, these chronic diseases, and there's an important concept here that I should write on the other page when I come back to it, but it's called the epidemiologic risk transition. And this is especially important as countries are moving from low to middle income countries to being higher income countries, where we see people living longer, and now they're living long enough so that they're having these chronic diseases, and so there's this growing burden of chronic diseases as compared with infectious diseases and injuries. So epidemiologic risk transition, I'll write that on the page when I come back to it, but that's an important piece when you think of age overall. And then the 70 plus, this is really the majority of people in this age range are in developed, or not developed, in the higher income countries, and then you see that chronic disease area expand even more. But if you look at injuries, then falls is a major underlying cause of mortality. So before we didn't have falls as much, we had other kinds of injuries, and so you can see even within the areas that as the age range progresses, that we start seeing different kinds of causes within different age ranges. So if you think back to our talk about standardization, one of the very, very common things that we standardize on is age, because it's such an important piece of what really is influencing this the patterns of disease. So we want to take that effect out so that we can see other things. But if we want to see the effect of age, we would not age standardize. So a lot of times when we're looking at differences across age groups, you'll see age crude. And you'll see that mentioned in a lot of graphs that maybe are in published papers or your textbook. So let me write the epidemiologic risk transition here. And again, that has to do with the growing burden of chronic disease as people start to live longer. So another thing that I like to remind people in terms of the age is that it is very helpful to know the top 5 causes of mortality for each of those age groups, specifically for the United States. And so we look just kind of at the big picture. You can go to GBD Compare or someplace else, and as you're understanding those top 5 for each of those major age groups, then it really helps you to frame a lot of questions in public health. The second thing in terms of person that can be very important to look at these patterns of disease would be a person's sex. And if you think about a lot of risk factors, like let's take smoking and lung cancer. There is a great graphic in your textbook, and let's see if I can find the page for you really quickly, that shows how that risk of lung cancer for men and women actually peaked at a different time. And so it's on page 172, and you'll see that the peak for lung and bronchus cancer for men, which is the top figure, really peaked around 1990, the year 1990, and the peak for women was closer to 2000 or a little bit after. And so we know that there are differences in when the different sexes took up smoking, and so a lot of times we'll see differences based on sex. If we were to group by sex, just because of differences in the way men and women approach their life, so that we'll see these differences based on gender, and sometimes then that can be an important thing that we need to be looking at in terms of trends. The next one is marital status. And usually the 3 categories that we see are single, for whatever reason, married, divorced, widowed, single, never married. So single, often we'll kind of either lump those together or break that apart. Then married, so officially married, have a marriage certificate. And then a third category is cohabiting. And a lot of times we can look at important differences in mortality or other health indicators based on marital status. Specifically, married individuals have a lower mortality, especially men. And you can think of this as being the fact that a person is married is protective. And so coming home to a house that has another person helps kind of with possibly mental health issues. It helps a person to keep doing things. Maybe they have more of a mission in life, or they have someone to watch out for them and care for them if something's up. And so this could be considered protective, or it could be selective, that people who display those characteristics of being able to be whatever characteristics might be associated with being married is selective of a healthier population. And so then the healthier individuals are more likely to get and or stay married. So those a lot of times we think that whatever it is that is this pattern, that this would be the thing that leads to the health outcome, and it's not always the case. So things like marital status could be either protective, or because of selection, those health outcomes are actually the thing that decide whether a person is married or not. So selective, and you'll see this over and over again. It's kind of reverse cause and effect when we start talking about causation. And so another example of marital status impacting a person's health is that young men who are widowed are much more likely to attempt or commit suicide. And so we have this very selected group. We have something that's a combination between age and a specific type of marital status. So they're single, but they're single for a specific reason, which is that their spouse passed away. So that particular combination can be associated very strongly with specific kinds of disease outcomes. The next one deserves quite a bit of discussion, and that is that of race ethnicity. I'm just kind of filling it in here. Probably should have left myself a little bit more space. Race ethnicity. Did I spell that right? Okay. Race ethnicity. And first of all, this whole construct comes to us from a group of specialists called cultural anthropologists. Epidemiologists do not make up the categories for these. They don't make decisions about that. And so the language that we're using comes from somewhere else. Cultural anthropologists have studied race ethnicity, and they have designated how we name the categories, and specifically how the CDC and other organizations group people in terms of race ethnicity. This is a very rapidly changing field, specifically race ethnicity. Even recently, we've seen a lot of categories that were added, such as multi-race, multi-ethnicity, that we didn't have even 20 years ago. So this is a rapidly changing field, but what I'm going to share with you is what is current. So what we currently have is, in terms of ethnicity, we have Hispanic or non-Hispanic. And then in terms of race, we have Black, or I should say Asian, Black. Some people will say Black or African American. It's problematic no matter what words you use. I'm not using any specific thing to be offensive. I'm simply trying to use what is commonly used by our public health system. So Asian, Black, sometimes we'll have Pacific Islander, and white or Caucasian. And so often also in the United States we'll have Native American or American Indian. So there are multiple combinations. But the thing that I want you to take away from this is, as soon as we have Hispanic or non-Hispanic for ethnicity, because these are ethnicity terms, and then we have Asian, Black, Pacific Islander, and white, we can have multiple combinations there. We can have Hispanic white, Hispanic Black. Those are the two most common. We also designate, because Hispanic is commonly white or Black, we designate non-Hispanic Black and non-Hispanic white. And so the way we typically then break these apart are that we have we first designate Hispanic or not Hispanic, so we end up with a Hispanic race ethnicity. Once we combine them into one category, we end up with Hispanic, and then we have Asian, often combined with Pacific Islander, so API, non-Hispanic Black, non-Hispanic white, and then we lump many people into an other category. We can split this out if we have a population that we think there is a subset that would be meaningful, that would be large enough to be able to give us this ability to describe the pattern for them. If it's really small, then it really doesn't help. The multi-race ethnicity often goes into other, just because we're still grappling with how to do this. So we end up with a group that's Hispanic, Asian Pacific Islander, non-Hispanic Black, non-Hispanic white, and other. Those are, if ever you see kind of 5 groups, those are bound to be the 5. So a lot of people will argue those are unfair groupings, that doesn't really describe what it is that we're trying to get at. And I think many epidemiologists would agree with you, and there has even been the suggestion to do away with race ethnicity altogether. However, as long as it is helpful in describing a pattern of disease, then it will help us to evaluate trends. And even more importantly, it will help us to allocate resources to groups that are either underserved or underserved, or we have health disparities around that. And so usually when you hear the conversation, or often when you hear the conversation about health disparities, it is around race, ethnicity. So let's talk about a couple of important pieces to this. First of all, in public health, you must know that the non-Hispanic Black population has the highest rates of mortality pretty much across the board for just about every kind of health outcome that we see. So non-Hispanic Black has higher infant mortality, higher maternal mortality, higher mortality from just a plethora of different diseases. They have higher incidence of disease. They have worse outcomes when they have the same exact disease at the same exact stage. So non-Hispanic Black often is, and rightly so, a focused group where we tailor the resources that we're delivering, that we make special attempts at focusing our attention on that population. And here's why. Let me draw this for you. If we have, and this will apply to our discussion on socioeconomic status as well, but if we have different race ethnicity groups and the averages for a particular, like if we say mortality is increasing going along this continuum, if we have a group that consistently demonstrates that they're at the highest end, and we can address that and bring them down to the rates of the other groups, then that gives us the most effect, because if our average before was here, and we can bring the average for this other group down significantly, then we will move the needle more than if we're trying to address the groups on the lower end. Maybe there's kind of like a sort of unspoken minimum, and there's not very much that we can impact those groups that are already having a lower pattern of disease. So if we can address the group that is in the highest risk, the probability of an event occurring during that specified time period, they have the highest incidence, then we can make the most impact on the trend for disease, and we do that by thinking about allocating resources to that specific group. So that's kind of an important piece with the non-Hispanic Black group. The other one, and I just want to emphasize, this race ethnicity idea is a social and cultural construct. It is not considered to be biologic. So this is based on a person's self-identified race ethnicity. When we think about the Hispanic group, often there's kind of this paradox where Hispanic people and families tend to have a lower socioeconomic status. However, they also tend to have a lower mortality. And so we have this confusion because, as we'll talk about socioeconomic status soon, even though they on average have what would seem like is a higher risk, they have a low socioeconomic status, so maybe they don't have access to care, they also tend to have a lower mortality. And so this deserves actually a little bit more discussion, because I think it will help you. You can apply this same concept to other where you're seeing patterns of disease. You can say, well, maybe what we're seeing really is due to something that's underlying this pattern that we think we're seeing is based on race ethnicity, but it really can be attributed to something else. First of all, in the Hispanic population, we're thought to be underreporting. And if you think about it, if somebody is in a group that maybe is skeptical of the medical community, or they maybe don't have as much access to it, then if something were to happen, then that particular event would not be captured by our current system, which is people go to the clinics and the hospitals. If they're accessing care or finding ways of getting treatment in ways that aren't captured, then we're having underreporting. There's also something, and it has a specific word, but I want you to understand the concept behind it. It's called the salmon bias effect. Salmon bias. And if you think about salmon, or even just fish in general, a lot of times they will go back to the specific location where they were hatched. They'll go back to that river or that area of the ocean when their life cycle is close to ending. And so the salmon go back to that particular river and then they die there. And so if you think about the Hispanic population, a lot of times they have very close ties still in their country of origin, and it's geographically close by. And so if they still have family ties in Mexico or in South America, they're able to go back to their country when they get to the age where they're like, well, I'm not working anymore, I'm not making income, I'm not a worker, I would like to go back to be close to my family in my golden years and live in my country my country that I love. And so they go back to their country and they die there instead of being captured as a death in the United States. So we have this very unique set of population where the age distribution may actually be different, or people in specific age groups where as they're starting to feel sick and they know that they're going to pass away, they want to be buried in their home country. And so there's this what's called the salmon bias. They migrate back to their country when they feel that the time has come that they're going to pass away. The other thing that's related to that is something called healthy migrant. And the healthy migrant effect is that even within, say, the working age group, that kind of like older teen to sort of upper 50s, that remember we saw that age group was the healthiest when we looked at age. Even within that group, if a person is not healthy enough to work, then they would not come to the United States to work and earn money for their family to send back to their family. And so there's this tendency to have a healthier group just from the get-go that has come to the United States. Now, as generations go by and people identify more with living in the United States and calling this their home country, then some of those actually go away. The underreporting might go away, the salmon bias might go away, the healthy migrant might go away. But there's a fourth reason that is thought to be a strong reason that despite this difference, this low socioeconomic status on average for Hispanic families, that they still have a low mortality, and that is one of culture. And this has been described extensively in infant mortality literature, where we see quite an elevated infant mortality for our non-Hispanic black babies. However, Hispanics who have a very close socioeconomic status to black families do not see that. In fact, in some areas, the Hispanic infant mortality is lower than all other groups. It's the lowest of all. And so we can attribute this to the concept of culture. And remember, race ethnicity is a social and cultural construct. It is not biologic. It's not considered to be biologic. So in terms of culture, there are a lot of things that happen when a baby is born. Grandma often comes for not just days or weeks, but sometimes for extended periods of time. They have an extensive social support system, even if they don't have immediate family that's close by. Other families will take them under their wing. And so this infant has a lot of very close observation by a wide variety of very experienced people who maybe they are a grandma or an auntie, and so they know what babies, if the baby's in trouble, they know to get care early. And so this cultural piece, often even multiple generations into living in a new location, often that part does not go away. And so if you think about just kind of like the unwritten rules of your own family, and then you've kind of gotten to know a friend and you go to their house or you meet their family and you're like, wow, your family's quite a bit different than the way my family runs. And so, different, just the way you function on a day-to-day basis. It's sort of like expected that we get together for these events, or that we have this level of closeness and that kind of thing. And so as you think about even just all of these different reasons that we see patterns of disease, because if we're saying that disease is not just randomly distributed through the population, we're looking for patterns, then these are the kinds of things that we might see even within other particular descriptives. There are differences in terms of, and here I'm starting to kind of bleed over into place, but I'll say nativity, whether a person was born in that country or not. There are differences in terms of religion. I mentioned before the whole idea of socioeconomic status, and usually we measure that by education, trying to measure it indirectly by education or income. But really what this is getting at is sort of a graded, kind of from lower to higher effect on a person's pattern of disease. And generally those in the lower socioeconomic status tend to have a higher incidence of disease. They have a higher risk of that event happening in any given time period. And so there are a couple of things that I want to point out in terms of socioeconomic status. First of all, going back to this whole notion of a higher risk group, if you think about having an impact on society in general, a lot of times we compare ourselves from one country to another, and we'll get to that when we talk about place. But if we can have an impact on the lower socioeconomic status, a lot of times the countries that have been successful in having an impact, that has been their exact approach, because there is kind of like this cutoff. At some point you do have a certain mortality or a certain limit to the expected age, life expectancy at birth. But if you can have an impact on those that are the lowest, that will then improve your average for everybody. Another concept that is related to socioeconomic status is, and there's a specific example for this, is with where we see increased mental illness that's associated with the lower socioeconomic status. And so this is also thought to possibly go both ways, just like marital status. You remember we looked at being married can protect you from disease, but having disease can select for people who get married also. So it's kind of this bidirectional. So when people were looking at mental illness and socioeconomic status, a lot of times we think, well, does the being low income or low education, does that, having that set of events in your life, does that lead to mental illness? And in some cases, I think the argument is pretty strong that yes, it does. If you've had a series of events that you've had to endure, these conditions of living in the lower social class, that could be a risk factor for specifically depression. Maybe you've had a spouse pass away, you've lost your job, you've had these particular events, and now you're kind of enduring these conditions of living in the lower social class. That is kind of like, it leads to a breaking point. And if you could take anybody and you could subject them to those particular conditions, and we would see an increase in mental illness. And so helping what I think the Bible calls the least of these really often is helping people to rise up to a level where they are able to cope with certain things, giving them the support that's needed in that situation. So being low socioeconomic status can lead to mental illness. But also, the reverse is true. It can go the other direction, where, and this has a special name. It's called downward drift. And I'll talk about where that name came from here in a minute. But the idea that having a mental illness can actually lead to a decrease in earning potential, therefore a decrease in socioeconomic status. Having a mental illness can make it less likely that a person is able to complete a higher level of education. And so we see this often where a person needs to have certain accommodations due to their mental illness, and those accommodations can't necessarily be given for a particular job, or there's unwillingness to do that. And so if we have a situation where, say, either an educational or a job situation where we can make those accommodations, we can actually help prevent what, if a person has a mental illness, that doesn't necessarily mean they can't perform a job or they can't be a contributing member of society. They may just need to have accommodations so that they can still have a level of income that will support them in what they need. So this is another example of something that goes both ways. This downward drift theory actually came from studies that initially that were looking at schizophrenia, and they tended to notice that there was a lot of schizophrenia that was concentrated in the impoverished areas of cities. And so they said, does living in the impoverished area of the city cause a person to become schizophrenic? And I would say probably not as likely a connection as say depression, but or is it that having that mental illness actually causes a person to be homeless, causes a person then to be sort of focused in this impoverished area of the city because it's an area where they're not likely to be noticed or kicked out or identified as much as if they were trying to live as a homeless person in, say, an upscale area of the city. Somebody would be more likely to notice your little tent or your place that you sleep at night. So that's downward drift, where the mental illness actually causes you to drift down to the lower socioeconomic status. So those are some of the common things that we think about in terms of person: age, sex, marital status, race, ethnicity, nativity, religion, socioeconomic status. In terms of place, then often we're thinking about, because of the place that you live, that would help to describe these patterns of disease. And probably the first one that we think about is this life expectancy at birth. If you were, by country, let me get a different color. So by country. In the U.S., at birth right now, or around about this time period, the average life expectancy for men is 75 and the average life expectancy for women is 80. And if you were to look in some of the higher, the countries that have a higher level than them, there are quite a few of them, say in Japan, which I believe recently had the highest, the average life expectancy for men was 78 and the average life expectancy at birth for women was 85. And so we see this difference, and a lot of times people will point out that the difference is not in our higher age group. If we were to look, not age, in our higher SES group, if we were to look in our higher SES groups, our US would match those of many other countries. But because our lower SES groups are so much lower, then what that does is it pulls the average down, so that risk of disease is happening so much more often in our lower SES groups that it's impacting our overall average life expectancy at birth. And so identifying those trends and allocating resources to those people that need them the most really is going to be the thing that has the greatest impact on something like our country's average life expectancy at birth. We see things like infectious diseases that are very much place oriented. If you think worldwide, a lot of the infectious diseases, the uncommon ones, happen in low to middle income countries. Very infrequently do we have these kind of rare tropical diseases in the higher income countries like Western Europe and United States and Canada. And so infectious diseases are, there's a pattern there where they're located in specific locations. The other thing, and I actually have a picture of this, is something called the stroke belt in the United States. And so if you look at heart disease and other kinds of disease, they are generally concentrated in different places in the United States. And so this area in the southeast part of the country is considered to be the stroke belt. And we have a lot more vascular disease. The blood vessels aren't working right, and so we have heart disease, we have more heart attacks, and we have far more strokes because the health of a person's blood vessels really impacts whether they are at risk for having that increased disease. So the stroke belt and cardiovascular diseases is an example of place. The other kinds of things we think of with place are urban versus rural. So let me actually add kind of like infectious disease, the stroke belt, and this urban versus rural. Now we see certain things in urban areas that we're less likely to see in rural areas, and often those things are related to being in close contact. Often we see infectious diseases more concentrated in urban areas because people are more likely to contact each other. We often see poverty located in more urban areas, and then we also have environmental exposures that are concentrated in urban areas, such as our whole history with lead-based paint. Now, lead-based paint was outlawed quite a long time ago, and so we don't technically have lead-based paint right now, but we would we still see the residual of that in houses that were painted with lead-based paint. And so in terms of place, we might see differences in detection of disease, we might see differences in the social or demographics, we might see differences in environmental exposure, and also in lifestyle and behaviors. The final area is that of time. And so if we were to think about time, we see three things. First, we see cyclic fluctuations. Next, let's see if I can fit all of these on here. Next, we see the secular time trends. And I'm going to explain each of these pretty quickly, and then we see clustering. And by cyclic fluctuations, what we mean is usually we see seasonal variations, and we see this with influenza. We see this, where in the winter months it happens, and then in the summer it tends to go much lower. But we also see this not just with infectious things, but we see this with birth rates. They tend to be highest in the late spring, I believe. We also see this with depressive symptoms. As the days get shorter, the depression kind of tends to surface. We see this with drowning. Drownings are much more likely in the summer months. We see this with injuries on the farm workers in rural areas. And so we see seasonal variations in a lot of things. That is opposed to what we call secular time trends, which is this whole idea of trends happening over time, where over the years, this is much longer, we see a trend either going up or down. Now, within that, we might see these cyclic fluctuations, but if the influenza has a cyclic fluctuation that's low in the summer and high in the winter, we might also see a change over time, over years and decades, where we're seeing less influenza or something because we're doing a better job with managing the disease or managing spread, or better job with immunizations. So mortality, cancer, these are good examples of secular time trends that we're looking at over long periods of time. Also, this whole idea of clustering. And the definition of clustering is an unusual aggregation of cases. It's usually according to space and time. And so remember this whole idea of location and time. In order to see a cluster, we have to have a specific population that we're in. And usually, excuse me, sorry, I had to let somebody in the door. Usually we see this idea of clustering in terms of space and time, and a classic example of that is the whole idea with John Snow and the cholera outbreak that he identified, and you'll be hearing more about that in this class. The other kinds of things that cluster are asthma. We also see clusters in terms of suicide. We might see clusters due to a common exposure, and asbestos is actually a really good example of that, where we had workers that were exposed to asbestos, and so they had a much higher rate of certain diseases, specifically lung cancer, especially if they were smokers. And so, but often what we think of as clustering actually is just random error. So we might see more cases of something, but it's not really a true cluster. So don't always think of cluster as the very first thing, but that is another thing that we see in terms of time, usually location and time. So that concludes our idea of concept of risk for disease. Thank you for joining me.